Hello guys, welcome to another video. This one is paper 1-2 of May-June 2020 of Add Math. So let's move on to question number 1. So here you have on the axis below, sketch the graph of y equal to modulus of this function. So whenever you see sketch, it means that it doesn't have to be exact. It can be an approximation of this graph. Now, showing the coordinates of the points where the curve meet the axis at basically the y-axis and the x-axis. So the first step always, as I do, is the first step is to ignore the modulus. So first step, let's just say y is equal to x minus 2 x plus 1 times x plus 2. So first step is to ignore the modulus. Now we need to know where does this meet the axis. So one by one, you say at the x-axis, we know that y is 0. So replace, you will have x minus 2, x plus 1, and x plus 2 equal to 0. Now we can solve for the values of x. So x will be 2, x will be minus 1, x will be minus 2. Now same thing, you would say at the y-axis, x is equal to 0. So let's find the value of y. Y will be 0 minus 2 times 0 plus 1 times 0 plus 2, which will be minus 2 times 1 times 2, which is minus 4. So here we have another point, which is 0 minus 4, and here we have all these points on the x-axis. Now let's try to label the x-axis to see where can we plot the points. So here we have 1, 2, 3, 4. So let's mark this as 1 and 2. And same thing on this side. So let's do this as minus 1 and minus 2. So the first point we have is 2, which is this one. And we have minus 1, this one. And 2 minus 2 for this one. That will be on the x-axis. Now for the vertical axis, let's see how can we plot those. I will label this as 2, 4, and this one will be has same scale for these ones. It will be minus 2, minus 4. So here we have the point 0 minus 4. Okay, now you can see that between those two, you have to know that, okay, this will be, if you expand the brackets, you will have a cubic curve. If you have x power 3, if you expand the brackets. And for this kind of curve, it has a maximum point, also has a minimum point. So it will have a shape like this. Okay, so this is good to know. Now you will see that here we have 2 points cutting this. The curve will cut this axis at 2 points. So you have to know for the value in between, does it go up or is it down? So let's see. The value in between will be minus 1.5. So let's replace in the equation. So let's do minus 1.5. So replace in the equation minus 2 times minus 1.5 plus 1 minus 1.5 plus 2. That will be 0.875. So it will be about this value right here. That is good to know. So basically for this part, it will be like that. For this part, it will be like this. Now for this one, so we have minus 1 till 2. So we have 1, 2, 3. So 1.5. So 1.5 will be here. So at this point, let's see, is the value up or down? So same thing, replace. This value is 0.5. So for x equal to 0.5, so 0.5 minus 2, 0.5 plus 1, and 0.5 plus 2. That will be minus 5.625. Will be about, so this will be about here. It doesn't have to be exact because it is only sketch the curve. So now you know a few values. So let's first draw this curve, which is not the actual answer. It's just a curve without the modulus. So let's do that. So of course you will be using a pencil. I'm using a pen, so it will be different. So at first you will just connect this one to this point, and this goes through this one, and this one goes to this one. Of course you can continue this down and this going up. Right. Now the next step, so you have to remember this curve is the curve without the modulus, but your answer needs to be with modulus. So anything that goes down below this curve have to be going up. So how do we do this? Pretty easy. So everything that is here reflect back up, so this will be about here. This point will be about here, and that's it. So let's do that. So this will be going up, so that will continue on this side, no problem. So at least for this one, it has to be this one. So make sure your curve is more smooth than this. Mine is not too great. So the blue one will not be your answer. The red one is your answer for your final answer of this curve. So it has to be this shape, and then this has to be going up. Okay, so it has to be like this, and this will be going up as well. So the blue one is just the curve without the modulus, but in the end it will be the red one as your answer. So the step will be first show the normal curve, so you have the shape of the curve, and then for everything that goes below has to be reflected upwards for the modulus. So that's how you draw this curve. This will be question number 1. Remember, the answer is the red one and not the blue one. Since you'll be using a pencil, you can just erase the blue one and you will have the red one remaining for you, and that will be your answer. This will be y equal to f of x for the function. Okay, so that will be question number 1. So now let's move on to question number 2. The volume V of a sphere of radius r is given by this. This is just the volume of a regular sphere, 4 over 3 pi r cubed. Now the radius r centimeter of a sphere is increasing at the rate of 0.5 centimeter per second. So basically this means dr by dt is 0.5 centimeter per second. This is given to you. Now question, find in terms of pi the rate of change of the volume of the sphere when r is equal to this. So we have to find rate of change of volume dv by dt when r is equal to 0.25. So now question is, how do you find dv by dt? As you can see the formula here, dv by dt is equal to, so we have to have dv on top over something times dr on the bottom. So what connects these two together? So this will be dt. So what connects these two? As you can see, dr connects these two functions. So we first have to find this and find this. This is given to us actually, will be 0.5. So we have to find this when r is equal to 0.25. So since we have v is given to us as 4 over 3 pi r cubed, this means dv by dr is 4 pi r squared. Now we have to replace the value of r equal to 0.25 to find the value. That will be 4 pi r squared 0.25 squared. That will be 0.25 pi. So let's test. 0.25 squared times 4, that will be 0.25 pi. That's for the value of dv by dr at r equal to 0.25. You have to let pi remaining here because your answer needs to be in terms of pi. That's why. Now the next step is to replace back in the equation. So dv by dt is equal to dv by dr will be 0.25 pi times dr by dt, which is 0.5. It is given to us. So now let's do 0.25 times 0.5. That will be 0.125 pi, and that will be centimeter cube per second. Cube because it is volume, and time will be per second. So this will be your answer for question number 2. Now question number 3, we have part A. Find the first 3 terms of this expansion. In ascending powers of x, give each term in the simplest form. So I hope you guys know how to do this by now. So pretty easy. Term by term, the first term will be 6 choose 0 times 4, that's the first term, power 6, times minus x over 16 power 6 minus 0 is 6. Now plus 6 choose 1, 4, 6 minus 1 is 5, and then minus x over 16 power, so this is 0 actually, 0, this will be 1. And the third term will be 6 choose 2 times 4 power 4, and then minus x over 16, this is 2, 2. The first 3 terms. Now let's simplify. This will be 1 times, what is 4 power 6? That will be 40, 96 times 1. Now plus 6 choose 1 is 6. Now what is 4 power 5? That will be 1024. 1024. This will be minus x over 16 plus 6 choose 2. That will be 15. And what is 4 power 4? That will be 256 x squared over 16 squared. That will be 256 as well. So now we have to simplify. This one will cancel out. And the first term will be just 40, 96 plus. So what is this one? So 6 times 1024 times 1 over 16. That will be minus 384x. And this one becomes plus 15x squared. So let's rewrite this down properly now. So the first 3 terms in the simplest form will be 40, 96 minus 384x plus 15x squared. That will be the first 3 terms. Now for part B, so whenever you see hence, it means you have to use part A, right? Now it says, hence find the term independent of x. So this means that x, the term in x power 0, which is basically without x, in the expansion of this. So what is this term here? Let's expand, we'll see. This is equal to x squared minus plus 2 times x times 1 over minus 1 over x, and then plus 1 over x squared. So simplify this, that becomes x squared. This one cancel out, become minus 2 and plus 1 over x squared. So you have to find the expansion, this term in the expansion of this. So using part 1, so when you see hence, you have to use part 1. So what are the first 3 terms? So the first 3 terms of this was 4096 minus 384x plus 15x squared. So what will be the term without x? So here we can just be selective, not expand everything, because you don't need to expand everything. You just need to find the term without x. So you know that if you take this first term, multiply by this one, will be without x. So 4096 times minus 2. How about this one? If you take this term, can you multiply by something? No, so it will not be possible. This will not be possible. How about this one? If you take 15x squared, you have to multiply by this one, which is 1 over x squared, for it to become without x. So 1 by 1, this one cancels out. This one becomes 4096 times minus 2. That becomes minus 8192 plus 15. So plus 15, that will be minus 8177. So this will be your term without x. So the term independent of x in this expansion. So that will be question number 3. Now question number 4, part A. Find how many different 5-digit numbers can be formed using the numbers. We have 6 numbers here. If condition, each digit may be used only once in any number. So pretty easy. So we have 6 numbers here, and we have to form a 5-digit number. So we draw 5 boxes, 1, 2, 3, 4, and 5. So what numbers we can choose here? So here we can choose any number. So we have 1 option, 2, 3, 4, 5, 6 options. So we can choose 6 options of the number. So let's say we choose 1. Remaining will be the rest. So here we have 5 options. Let's say we choose 2. Remaining will be 4. Let's say we choose 3. And that will be 3 options. Let's say we choose 5. And the last one will be 2. So the answer will be this times this times this and times this. So 6 times 5 times 4 times 3 times 2. That will be 720. So answer part 1 will be 720. So if you guys know how to use permutation, this is pretty straightforward because we have 6 numbers. We have to choose 5. We have to form a 5-digit number. You can just write 6 permutation 5. That will also give you the same answer, 720. Okay. Now moving on to part 2, it says how many of these numbers, which is 5-digit numbers, are not divisible by 5. So how do you know a number is divisible by 5? The number ends with 0 or by 5. Right. So if it is not divisible by 5, so it cannot end with those two. So again, we have the same numbers, which is 1, 2, 3, 5, 7, and 8. So we have 5 squares for 5-digit numbers. Okay, 5 squares. Now for it to not be divisible by 5, you can end with 1, 2, 3, 7, 8. So we have 5 options of ending. Let's say we choose 1. And the rest we can choose any numbers. It can be 2. So let's say 2. That will be 1, 2, 3, 4, 5 options. Let's say we choose 3 here. So we have 4 options, 3 options, and 2 options. That should give you your answer. 5 times 4 times 3 times 2 times 5, that will be 600. Or you can write this as, so whenever you have to choose from the rest, you can just write, so this is the only condition here. That will be, you can finish by 5, will be only, you can choose any numbers. That will be 5 options. And the rest, we have remaining 5 numbers. We have to choose 4. So that could be your answer as well. So 5 permutation 4 times 5. Same answer. Now for part 2, it says how many numbers found in part 1 are even and greater than 30,000. So here we have 2 conditions. We have even and bigger than 30,000. So whenever you have 2 conditions, you have to do one by one. So we have the numbers 1, 2, 3, 5, 7, 8. So how do you know a number is even? It has to end with an even number. So here in this question, it can end with 2 or it can end with 8 to be an even number. So let's do case by case. So case number 1, let's say it ends with 2. So ends with 2. So again, we have 5 boxes for 5-digit numbers, 3, 4, and 5. So here we assume already it ends with 2. So here we have only 1, 2. That will be 1 option. Now for the rest, we have another condition. It needs to be bigger than 30,000. So for it to be bigger than 30,000, let's see what option can we have for this first number. So 1 is not good. 3 is good, so 1 option. 2, 3, 4 options. So 4 options will be for the first one. So let's say we choose 3. Remaining number will be, so we have choose 2 already, will be 1, 2, 3, 4 numbers remaining. So times 4, and then 3, and then 2. That will be case number 1. So 4 times 4 times 3 times 2 times 1, which is 96. So now you have a case number 2 where it ends with 8. So same steps. You have 5 boxes, 1, 2, 3, 4, and 5. So you have chosen 8 already. That will be only 1 8, so one option left. So let's say 1, 2, 3, 5, 7, 8. So 8, only one option, so that will be gone. Okay, 1. Now for it to be more than 30,000, it has to begin with, it cannot begin with 1 or 2 because it will be less than 30,000, so it can only begin with 3, 5, 7. So 3 options. Let's say we choose 3. That will be here. Now for the rest, we can choose any numbers, so we will have 4 options left. That will be 4, then we have 3, then we have 2. Times, 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 and times. So 3 times 4 times 3 times 2 times 1. That will be 7, 2. So now the answer will be the sum of these two. 96 plus 7, 2. That will be 168. So number of numbers, that is 168. So this plus this will be 168. That satisfies these two conditions. That will be part A. Now let's move on to part B. It says the number of combinations of n items taken from 3. So n items, taken 3. So n items taken 3 is equal to, at a time is 6 times, so 6 times the number of combinations of n items taken 2. So we have this equation, we have to find the value of n. So what is this? Let's see, we do have a formula sheet. So you observe, this is just that. As you can see, this is your formula for n choose r, which is n factorial over n minus r factorial r factorial. Now we have to use that to find this value. So first one, what will be n choose 3? So let's write this here. N choose 3 will be the same as this. So n will be n factorial. So r will be 3 here. So n minus 3 factorial and 3 factorial. And here, what is n choose 2? That will be n factorial over n minus 2 factorial and then 2 factorial. Now replace back in this equation, you will have, so here we have n factorial over n minus 3 factorial and 3 factorial equal to 6 times n factorial over n minus 2 factorial and 2 factorial. So these two will cancel out. And what is this value? Let's find out. So 3 factorial is equal to 6. So this is 6. So let's just expand this. That will be 1 over n minus 3 factorial. This is 6 equal to 6 over n minus 2 factorial. 2 factorial is just 2. We can check. So 2 factorial is just 2, right? Now we can simplify this. So 2 goes away. That will be 3. Now if you cross multiply, you will have n minus 2 factorial over n minus 3 factorial equal to 3 times 6 will be 18. So now how can we simplify this? So if you guys know, so for example, let's say we write 10 factorial. What is 10 factorial equal to? It is equal to 10 times 9 factorial. Same thing, if you write n factorial, it is n times n minus 1 factorial. So same thing here, if you write down n minus 2 factorial, it is equal to n minus 2 times n minus 3 factorial. So same way, replace here, you will have, on top you will have n minus 2 times n minus 3 factorial over n minus 3 factorial equal to 18. So these two cancel out. That will give you n minus 2 equal to 18. N will be 20. So that will be your value for n, 20. And this is question number 4. Question number 5, we have a function f of x equal to 2x plus 3 power 2 for x more than 0. Okay. Now part 1, find the range of f. So range of f will be the values which goes up and down. So let's observe. For values more than 0, so what we can do is we can just first say let x equal to 0. F of x will be f of 0 will be equal to 2 times 0 plus 3 square. That will be 9. So for x more than equal to 0, the value of f of x equal to 9. But x is more than 0, so f of x will be more than 9. This will be the range of your function. So as you can see, if the values of x increases, the value here will also go up. So it will always be going up. It will never slow down. Okay. Now part B, explain why f has an inverse. So the reason why it has an inverse is because you will write for the range, for the domain, x more than 0, f is a 1-to-1 function. So that is why it has an inverse. So now what does a 1-to-1 function mean? It means that if you draw a graph, so usually the graph of, this is x, y, so usually the graph of f will be somewhat like this. Let's say for example it's like this. We don't know. Somewhat like this. So 1-to-1 function means if you were to draw a line in this direction, it can only cut the curve at only one place. That is only when it can have an inverse. But normally it does not have an inverse, but since it is defined for x more than 0, so only 1, so this part will not be in the domain. We will only have this part. Since this line, so it can be any horizontal line, cuts the curve at only one place, it will be called a 1-to-1 function, and hence if it is a 1-to-1 function, it will have an inverse. Okay, that is the main thing you guys need to know. If a function f is a 1-to-1 function, it has an inverse. And how do you know it is a 1-to-1? You know this by, if you draw the curve, if you draw a horizontal line, if it cuts the curve at only one point, that is when it is a 1-to-1 function. Okay, now let's move on to part C. Find f inverse of this function. As you know, the first step is to let y equal to f of x, which is the function 2x plus 3 square. Now we have to try to make x the subject of formula. So we send square over here, it will become square root of 2x plus 3. 2x will be root y minus 3. X becomes root y minus 3 over 2. Now from this, as always, f inverse, it will be in terms of x, so you have to change y to x. That will be f inverse of x. Now part D, state the domain of f inverse. So by now you have to know that domain of f inverse is equal to range of f. So we know the range of f is equal to this. Domain will be x values will be more than 9. This will be domain for f inverse. Now for part E, given that g of x is equal to this, for this range, okay, find the exact solution of this. So first let's find this. So what is f g of x? It is f of g of x. That is basically replacing the value of x by g of x in f. So f is given by 2x will be g of x plus 3 square. That is 2 times ln x plus 4 plus 3 square equal to 49. Now you send this one over here, it becomes 2. This one will be ln plus 4 plus 3. This becomes 7. Square root of 49 is 7. Now let's continue. We send this one over here, becomes 2 ln x plus 4. 7 minus 3 will be 4. Now ln x plus 4 will be 2. Now x plus 4 will be e power 2. Now x will be e power 2 minus 4. So this will be your answer for the value of x. If you want to, you can always just solve it. Minus 4, you will have 3.39 if you want to. But this will be your answer for the value of x. And actually no, because here you have to find the exact solution. So this will be your answer and not this. So this will be question number 5. Let's move on to question number 6. So here we have the diagram shows a straight line 2x plus y equal to minus 5. So that is the straight line. And part of a curve xy plus 3. This is part of the curve. The straight line intersect the x-axis at point A and intersect the curve at point B. The point C lies on the curve and the point D has coordinates 1, 0. One is x and y coordinate. The line CD is parallel to the y-axis, which means it is straight. It is vertically above C. This is what it means. Okay, no big deal. Now for part 1, it says to find the coordinates of each of the points A and B. So let's do that. So for point A is the point where this line cuts the x-axis. So the line is 2x plus y equal to minus 5. As you must know by now, at x-axis, the value of y is equal to 0. Replace this on this equation, you will have 2x plus y, which is 0, equal to minus 5. So x will be minus 2.5. So the point A will be minus 2.5 and then 0. That will be your point A. That is your first answer. So now let's move on to point B. So how would you find the point B? So point B is the intersection of this line with this curve. So let's write down the equation of both of the line and curve. So first one is 2x plus y equal to minus 5, and the curve is x plus y, xy plus 3 equal to 0. So we have to solve this simultaneously. So first step, let's make y the subject of formula, become minus 5 minus 2x. Here we have y, replace y in this, you'll have x times minus 5 minus 2x plus 3 equal to 0. Expand the brackets, you will have minus 5x minus 2x squared plus 3 equal to 0. Now let's make this positive, become 2x squared plus 5x minus 3 equal to 0. Let's try to factorize this equation. So two brackets, then we have 2x squared is 2x times x, 3 is 3 times 1. To get plus 5, it needs to be plus 6 minus 1. So your value of x will be half, or it can be x minus 3. So which one is the correct value? So you go look at the drawing. X value is on the positive side, so it cannot be negative. So you will take this value for the x coordinate of B. Now what is the y coordinate? Y is minus 5 minus 2 times half, which is minus 5 minus 1, which is minus 6. So in this case, B will be 0.5 and minus 6. That is your point B on this graph. So now let's move on to part B. It says, find the area of the shaded region, giving your answers in the form of this, where P and Q are positive integers. So let's see where is the area that we need to find. So we need to find this area. So what is the coordinates of C? It will be 1 and that will be minus 3. So let's break this down into two parts. So as you can see, we can break this down right here into two parts. That will be area of this side and area of this side. This is B. B, as we have find, it is 0.5 and minus 6. So we have two areas. So one is this area and one is this area. This will be area of a triangle, as you can see, pretty easy. How do you find area of a triangle? This will be base, what is the length of the base? You know the x of here will be, for a will be minus 2.5. This is minus 2.5. And for b, it was x value here is 0.5. So this distance will be 0.5 minus 2.5, that will be 3. And what is the length? The height. The height will be minus 6, which is 6. So what is area of triangle? So area of triangle, that is the first part. Area of triangle will be half times base, which is 3, times height, which is 6. That will be 9 units square. That is the first part that we need to find, which is area of triangle. Now next part, what is this area? So as always, we can find the area by integration. Let's call this one area of B. It will be integration between the x values of this and this. So the curve have the equation x, y plus 3 equal to 0. So since we're integrating along the x-axis, we have to make y the subject of formula. So y becomes minus 3 over x. So integration, that will be between limits of 1 and 0.5, as you can see here, 1 and 0.5, which will be between the curve of minus 3 over x with respect to x. So let's see what value do we have for this one. So this will become, so I hope you guys know how to do this. That will become minus 3 ln x with limits of 1 and 0.5. So now if you solve this, you will have minus 3 ln 1 minus 3 ln 0.5. So ln 1 is equal to 0, so this becomes 0. So minus become plus 3 ln, what is 0.5? It is half. Now if you want to, because your answer needs to be an integer, where q is an integer, you can play with this number. So as you know, half is also equal to 2 power minus 1. So you'll write down 3 ln 2 power minus 1. Now this is a log. We can send this one on this side. You'll become minus 3 ln of 2. So now it is an integer. So that is good. But now what is this value? This value is just the area on this section. It is below the curve. That's why it is negative. So area cannot be negative. That's why we have to take the modulus of this. Area will be ln 3 ln 2 units square. Now what is the area of the region? It will be area of triangle plus this area. So area that we need will be 9 plus 3 ln 2, or you can write this in ln 2 power 3, which will become 9 plus ln 8. So this one will be your answer because it needs to be in the form of p plus ln q, where p and q are integers. So this is your answer for this question, part B. That is question number 6. Let's move on to question number 7, part A. Given that y is equal to this function, show that dy by dx equal to this, where a, b, and c are integers. Okay, so let's find out what are the values of a, b, and c. So how do you find dy by dx for this? As you can see, it is a product of this times this. So we can use the product rule. So dy by dx will be equal to, the first one will remain the same, then multiply by, so let's use a different color, d by dx of the other term, which is this one. Then we have to plus. Now we have to change the positions. The first one will be this one now, and then multiply by d by dx of the other one, x squared minus 1. Now we can simplify one by one. The first one remains the same, x squared minus 1 times d by dx of this. So as you know, you can write down this as 5x plus 2 power half. So d by dx of this will become half of 5x plus 2 minus half times 5, which is equal to 5 over 2 root 5x plus 2. Okay, so we can just replace the value here. This becomes 5 over 2, that will be 5x plus 2 at the bottom. And then that becomes plus, this is the same. And then we have to differentiate this, that will become 2x. Now let's, so this was just a side note. Let's continue here. Now the top will become, if you expand, that become 5x squared minus 5 over 2 root 5x plus 2 plus 2x root 5x plus 2. Now as you can see, this is a fraction with different base, so we can just find the LCM, which is basically 2 root 5 plus 2, and then we have to multiply this one. So this one has the base already, we don't need to multiply anything. We can just cross multiply now. That will become 5 squared minus 5 plus 2x, so times this, so this times this, so first we do this times this, so times 2, and then this times this becomes 5x plus 2. Okay, I hope that makes sense. So now if you were to simplify, that becomes 5x squared minus 5, and this becomes plus 4x 5x plus 2. So let's simplify this term. So we have 5x squared minus 5 plus 20x squared plus 8x, which becomes, if you simplify this, that becomes this plus this will be 25x squared plus 8 and minus 5 over 2 root 5x plus 2. So as you can see, this is basically the same as this, right? Which is a x squared plus b x plus c over 2 5x plus 2. As you can see, we need to express this in this form, which is equal to this, where the value of a is 25, b will. So now let's move on to part B. Find the coordinates of the stationary points of the curve for x more than 0. Give each coordinate corrected to SF. So as you know, at stationary point, we know that dy by dx equal to 0. Now, what is the value for dy by dx? So we find this in part 1 already. As you know, dy by dx is equal to 25 x squared plus 8x minus 5 divided by 2 times 5x plus 2 equal to 0. So let's solve for the value of x. So first step is to cross multiply. You will have 25 x squared plus 8x minus 5 equal to 0. So we have a equal to 25, b equal to 8, and c equal to minus 5. So x will be, using the formula, that will be minus 8 plus minus b squared, which will be 64 minus 4 times a, 25 times c, divided by 2a. 2a will be equal to 50. Okay, so let's do one by one. So 64 minus 4 times a times c. That will be x minus 8 plus minus root of 564 divided by 50. So let's try to find the value of one by one. So minus 8 have to be plus because values of x is more than 0. As you can see here, that's the domain. We have to use plus only. plus root of 564 divided by 50. That will be x equal to 0.31497. Now we have to write this down correct to 2SF. That will become x equal to 0.31. This is your x coordinate. Now you have to find your y coordinate by replacing x in this equation. So let's do that. That becomes, this is your answer for x. So answer square minus 1. Now times root of 5 answer minus plus 2. That will become minus 1.703. So correct to 2SF, that will become y minus 1.7. So your answer will be x is equal to 0.31, and that is y for the point. This is your stationary point. Now part C says determine the nature of this point. So usually what we do is we have to find the value of d2y by dx2 at x equal to 0.31. So one trick we can use here is, if you look at dy by dx, you will see 25 x squared plus 8x minus 5 divided by 2 times root of 5x plus 2. Now it is 4x more than 0. So you can just have a look on this top function. You can see that it is a quad function where this is positive. It means that it will have a shape like this. So in this case, you can just write quad where 25, so coefficient of x squared is equal to 25, which is positive. It can mean that the nature of stationary point is a minimum point. But of course, you can always find this d2y by dx2. Replace x, you must have a positive value. Then this proves that it is also a minimum point. So this will be your question number, I think it's number 7. Now let's move on to question number 8. The diagram shows a triangle OAB, so OAB, such that OA is A, OB is B. So OB is B, and OA is A. Let's write this here. Okay. Now the point P lies on OA such that OP is 3/4 OA. So which means if OA is 4, so if the length of OA is 4, OP will be 3 and PA will be 1, so that the sum is 4, which means here we have OP, so OP will be equal to 3/4 of A, and PA will be 1/4 of A. I hope that makes sense, right? It's just simple ratios and finding the values. Now, the point Q is a midpoint of AB. Okay, that is pretty easy as well. Now, the lines OB and PQ, so OB and PQ are extended to meet at R. So, OB and PQ has been extended to meet at this point R. So, part 1, find in terms of A and B. Part 1, AB. As you can see, AB is given by A going to O, OB. So, OB, AO plus OB. AO will be minus A plus B. So AB is minus A plus B. Now part B, find PQ, giving you answers in its simplest form. So how would you find PQ? So PQ will be this one. So since we know that Q is a midpoint of AB, and if you know AB, you know that AQ will be half of AB, which is minus half of A plus half of B. So finding PQ will be PA, AQ, right? So PQ is equal to PA plus AQ. So PA is given by 1 over 4A, and plus AQ will be minus half A plus half B. Now 1/4 minus half will be minus 1/4 A plus half B. So this will be the simplest form of PQ. This. Now if you want to, you can also remove, that's okay, you don't need to. I was thinking about, you can also take out the fraction outside. Let's say if you take out 1 minus 4 outside, you'll have A minus 2B. But you don't need to do that. That is enough for your answer. Now let's move on to part C. It is given that N times PQ equal to QR. Okay, so question C, find QR in terms of NAB. So QR is equal to N times PQ. PQ we know it is minus this plus half B. So QR will be minus N over 4A plus N over 2B. That is value of QR. Now for part D, find QR in terms of K, A, and B. So let's see. You see that BR is equal to KB. So where's BR? BR is right here. So here we have found the value of QR. QR is this. And we know QB is the same as this, which is minus half A plus half of B. So BR is given by KB. So write down KB here. So find the value of QR in terms of A and K. A, B, and K. So that will be QB plus BR. So QR will be equal to QB plus BR. Now QB, we know it is equal to minus half A plus half B, and BR is KB. So if you simplify, that becomes half of A and then plus half plus K of B. So this is also QR. Now next question, to find the values of N and K. So when you see hence, you have to use the previous answers. So QR is equal to this, QR is equal to this. So find the value of A of N and K. So as you know, QR is equal to QR. On one side we have this one, which is minus N over 4A plus N over 2B equal to this one, which is minus half A plus half plus K B. Now we have to compare the coefficients of the same variables. So here we have A, so we compare the coefficients. So we say minus N over 4 is equal to minus half. So find the value of N. So we cross multiply, that becomes minus 2N equal to minus 4, N will be 2. That's the first value of N. Now for this one, same thing, we have B here, we compare the coefficients. So N over 2 is equal to half plus K. So since you know the value of N already, so 2 over 2 will be half plus K. From this you have K equal to 1 minus half, which will be half. So value of K, N is 2, and K will be half. Okay, and that's it for question number 8. Now let's do question number 9, part A. A particle P moves in a straight line such that its displacement x from a fixed point O at time t is given by this equation. Now part 1, find the speed of P when t equal to pi. So as you know, speed s is equal to dx by dt. So let's first find speed. That will be dx by dt of this equation, that will be 10 cos of 2t times 2. This will become 0. So this is 20 cos of 2t. So you have to find the value of s when t equal to pi. That will be 20 cos of 2 pi. So now let's change the values to radians. Number 2, 20 cos of 2 times pi. That will be 20. Speed is meters per second. That is your first answer. Now part 2, find the value of t for which p is first at rest. The first time it becomes at rest. At rest, you know that speed is 0. So speed is equal to 20 cos of 2t is equal to 0. Find the value of t. So you would equate, you will have this equal to 0. Then you have 2t equal to cos of cos inverse of 0. Now you have to find the first value, so basically the acute angle that comes with this. Cos of 0 will be 1.57. So t will be divided by 2, 0.785. So this will be your value of t when it first becomes 0. So you can have many values, but you need to take the first value, which is the smallest value, for your value of t. So that will be the answer for this one. Now for part 3, find the acceleration of p when it is first at rest. So at rest it is time equal to 0.785. You have to find the acceleration. So acceleration is equal to d, so ds by dt. So we know s is equal to 20 cos of 2t. So ds by dt is equal to 20. That will be minus sine 2t times 2. That will become minus 40 sine of 2t, that is ds by dt, which is equal to your acceleration. Now you have to find the acceleration at time equal to 0.785. That will be minus 40 sine of 2 times 0.785. So let's find the value. What is this value? So minus 40 sine of 2 times answer. That will become minus 40 meters per second square. This will be the acceleration at time equal to 0.785. Now let's move on to part B. So here we have a speed time graph for the particle q traveling in a straight line with velocity v at time of ts. The particle accelerates at 3.5 for the first 10 seconds. So this one will be 3.5 meters per second for the acceleration for the first 10 seconds. And then travels with a constant velocity for 10 seconds. And the particle then decelerates at a constant rate. Then it comes to rest. Okay. The distance traveled during the interval 20 to 25 is this much. That is good to know. So now part 1, find the value of v. So we can find the value of v by using this first information. It says the acceleration for the first 10 seconds is equal to 3.5. As you know already, if you have a speed time graph, the acceleration is equal to the gradient of the triangle, which is equal to 3.5. So as you can see here, we have a triangle, right? This triangle. So gradient will be the height by the base. Height here will be v divided by base, which is 10, equal to 3.5. So v will be, by cross multiplying, you will have 35. So value of b will be 35. So let's write this down here, 35 for the value of v. Now moving on to part 2, find the velocity of q at t equal to 25. So find the value of v when t equal to 25. So find this value right here. So how would you find that value? So one way of doing this is use this information. It tells you that the distance traveled in this region, it is 112.5. So now you must know, when you have a speed time graph, distance traveled is equal to area under graph. So if you observe, this area is area of a trapezium. So let's do that. Well, how do you find area of trapezium? It is equal to half times sum of parallel sides. This one, let's call this one S. We don't know this height. S, and then plus this one, which is 35. 35 plus S, and times the height in between, that will be 5. It is equal to 112.5. Now we have to find the value of S. So we send this one over here and divide by 5. So 112.5 times 2 divided by 5, that will be 45. So 35 plus S equal to 45. So S will be 45 minus 35, which is 10. So the speed, so velocity of Q when t equal to 25 is going to equal to 10 meters per second. That will be your value of S right here, equal to 10, this height. Now the last question, it says find the value of t when Q comes to rest. So what is the value of t when Q comes to rest? So in this case, you can use the formula. As you know, acceleration is equal to final speed minus initial speed. So initial speed, you can write u divided by time taken. So let's first find the acceleration. So what is the what is the deceleration? In this case, that will be same, because here we have a constant rate. It can be height divided by base. So height will be 35, and base we don't know, which is, oh, actually we can find this out because we know this value already. Let's draw a new triangle. This will be our new triangle. This is our new height. So what will be this height? Will be this distance, which is 25, and the base will be 5. So the deceleration will be 25 divided by 5, which is 5. But the acceleration is minus 5. Right. So you replace here, minus 5. Final speed is 0. Initial speed was 35 divided by time taken. So the value of t will be minus 35 divided by minus 5. That will be 7. So 7 will be not this value, but the time taken here for the base is 7. Now for this value of t, that will be 20 plus 7, that will be 27. This will be your value of t. So let's call this t prime. So the value of t will be 20 plus 7, that will be 27 seconds. So this will be your value. And that is question number 9. Let's move on to question number 10. So part A, solve this equation, tan 3x equal to minus 1 for this domain. Now you observe you have 3x here, which means 3x will be between 3 pi by 2 and minus 3 pi by 2. Now that is the first step. And then you see tan is negative. It means that tan will be in this and this value. This will be 2 pi minus theta, and that will be pi minus theta. Right. So let's first find the value of theta. So let's forget about 3x, find theta. Theta will be tan inverse of the positive value will be 1, which is 45 degrees, which is pi by 4. Now find the values of 3x. 3x will be pi minus theta, which is 4 over 4 minus 1 over 4, that will be 3 over 4. And this one will be 2 pi minus theta, so 2 pi minus this becomes 7 pi over 4. Now since you have 3x here, you have to add 360. Let's do once, we'll see what happens. So add 360 to this one, you will have, so degrees will be 2 pi. So add 2 pi to each term. That will become, add 8, that becomes 11 pi over 4, and this become 18 pi over 4. But we have 3 revolutions, we have to add another 2 pi to these two, but you observe that 3x is actually in this range. So let's find out. It is over 4, let's make it 4 as well. 3 pi over 4, that becomes 6, and that will become 6 pi over 4. So this is clearly outside the range, so we don't need those values. So these two, we don't need the values, so we don't need to add another revolution. There's no need to do that. So this one will be also outside, but we have to use this to find the one on the negative side as well. So minus 2 pi. So let's do 3 pi over 4 minus 2 pi. That will become minus 5 pi over 4. And then we have minus 2 pi. That becomes minus 8 minus pi over 4. Right. So right now we have 3x is equal to minus 5 pi over 4 minus pi over 4, and that becomes, so we have this one remaining, 3 pi over 4. So we don't take this one because it is outside of the range, so we cannot take this one. So only 3 values. So here we want to find x. X will be minus 5 pi over 12 minus pi over 12 and 3. So divide by 3, that will become pi over 4. So this will be your values of x. And this is for part A. So now let's move on to part B. Use your answers to part 1 to sketch the graph of this. So the first step is always you need to know if your graph cuts the x or the y axis. So let's see. So our graph is y equal to 4 tan 3x plus 4. Now you will say at the x-axis y is equal to 0. So you will solve 4 tan 3x plus 4 is equal to 0. So tan 3x will be equal to minus 1. So you observe this is the same equation as this one. So the values of x will be the same as part 1, which is minus 5 pi over 12 minus pi over 12 and then pi over 4. This is where it cuts the x-axis. Now the next one you have to find at y-axis. At y-axis the value of x is 0. So y will be 4 tan of 0 plus 4. That will be 4. The point is 0, 4 where it cuts the line, the y-axis. Now if you look at this equation, y equal to 4 tan 3x plus 4, you can see this will be your baseline. Y equal to 4 is your baseline, and this is your amplitude, and this is your cycle. We have 3 cycles, and the period will be equal to, this is a tan curve, it will be pi by 3, which is 180 divided by 3, which is 60 degrees, will be your period. So let's see. For this one, let's see what can we have here. We will have, this is pi by 2, which is 90. So pi is 180 divided by 2, 90 degrees. So we will have a period every 60 degrees. So 90 minus 60, that will be 30. That will be right here. So that will be 30 degrees, which will be, so this distance, this, and this will represent one period. Right. Now let's draw our baseline as well. So we will have 4, let's name this as 4 here. So y equal to 4 was our baseline. Right. Let's say this is our baseline. Right. Okay, I think tan curve doesn't really have an amplitude because it keeps going on in the range of the asymptotes. So every 60 degrees will be a cycle. So 30 minus 60 will be minus 30, will be this one. So these lines represent the asymptotes of my curve. And again, that will be this one. And this is just your baseline, y equal to 4. Now let's mark all the points where it touches the x-axis. So minus 5 pi over 12 will be this point. Then we have minus pi over 12 is 15 degrees, so minus 15 will be this point. And we have pi by 4 will be this point. And lastly, we have this one where it cuts the y-axis. So as you observe, we have asymptotes and we have this one. So it will go up in this case. So here you have to change direction. So go up, but down. That makes sense. Go down here, and this will be going up right here. So same thing happening here as well. You will have to cut the curve somewhere around this point. Same thing here about this point. So it has to be going up and changing directions when it comes down to this one. So going up and changing direction in this one. So same thing here as well. Has to go up. So this one will be this shape, and this will be changing direction going up. Okay, so as you can see, this will be the curve defined in this region. So steps: first find out where your curve cuts your axis and you mark the points, and then find out the period of your curve so you can find the asymptotes. Every 60 degrees will be your asymptote for this curve, and then you just have to know your baseline where it changes direction, and that will be your curve for part B. And that is question number 10, and that will be the last question of this paper. I hope that was helpful, and as always, thank you for watching. I will see you soon.